Consider the equation a squared minus 16 times a minus 17i equals to 0. Here A is a matrix whose elements are a, b, c and d, where a, b, c, d are positive integers arranged in ascending order, and precisely 2 of a, b, c, d are prime numbers. These 4 numbers are also pairwise co-prime, and in this equation I is an identity matrix and 0, 2, 2 is a 2 cos 2 0 matrix. Now if B is equals to another 2 cos 2 matrix whose elements are b, a, c, d, then find the determinant of B. And these are the 4 given options. So if you want, you can pause this video and give it a try and then come back and see the solution. So let's start with this equation. This equation is called the characteristic polynomial of the matrix A, and we can also write PA of lambda is equals to determinant lambda times I minus the matrix A. So in this equation, if lambda is equals to A, then it will lead to a 0 matrix. Now expanding the determinant of lambda I minus A, we will yield a similar polynomial. So let's calculate this determinant. Lambda minus A minus B minus C lambda minus D. So if you calculate it, it will give you lambda minus A times lambda minus D minus BC. And this is equals to lambda squared minus A plus D times lambda plus A times D minus BC. Now for lambda equals to A, it should satisfy the given equation. Therefore, if we compare both this equation, then we can write A plus D equals to 16 and AD minus BC is equals to minus 17. Now in the question it is given that all the elements A, B, C and D are positive and they are in ascending order. So now let's focus on the equation A plus D equals to 16. Let us choose A is equals to 8, then D will also be 8 and it will satisfy the equation. But according to the question, A should be less than D as they are in ascending order. Therefore, A could be 7 and D could be 9, or we can say that A could take values from 1 to 7, not more than that. And D will be given by this equation D equals to 16 minus A. Now from 1 to 7, A could take any value, that is any even or odd values. But if A is even, then D will also be even. And then A and D will have 2 common factors 1 and 2. But in the question it is given that all the elements are pairwise co-prime. That is, they can only have one common factor and it should be 1. Therefore, we can conclude that A should be odd. That is, A can take value 1, 3, 5, 7. Now let's consider A is equals to 1. Then D will be 15 and BC will be 32 according to these equations. So one possible matrix is 1, 4, 8, 15, but here 4 and 8 are not co-prime, so it cannot be the solution. Now let's set A equals to 3, then D will be 13 and B times C will be 56. Therefore the possible matrix could be 3, 7, 8, 13. But according to the question, there are only 2 prime numbers, so this also can be the solution. So now set A equals to 5, then D will be 11 and B times C will be 72. Therefore the possible matrix is 5, 8, 9, 11. So now if you look carefully, then you will find that this matrix satisfies all the conditions given in the question. So this is our desired matrix, or this is the matrix A. Therefore the matrix B will be 8, 5, 9, 11. Now we need to find the determinant of B. Therefore determinant of B is equals to 8 times 11 minus 5 times 9, which is equals to 43. Therefore correct answer is option B. If you want to solve more problems on matrices and determinants, then please see the playlist. Link is in the description.